Okay, good afternoon, pilot teachers, and good afternoon, students.
Good afternoon, Ms. Rosalie.
Thank you. Sit down. Okay, today we'll see us look at the start of our term 2 work. And I hope you had a good holiday and you're back ready for more work. Okay, good. We have actually completed our work on looking at volcanicity. And if you did follow our little booklet, the booklet on Introduction to Physical Geography, you would have seen that the first part of the work in that booklet, it covered information on tectonic plate movements, it covered information on continental drift, and it also looked at information on volcanicity. The particular topic now that we are going to start on for this term on diastrophism is actually not in that booklet. But because we are looking at information on the physical building up of the land, it is also important for us to touch on the topic on diastrophism. So our lesson today will introduce the concept of diastrophism, and also at the end of the lesson, you should be able to identify simple types of folding under the topic on diastrophism. And that is what we are going to actually try to see if we can achieve by the end of our lesson today. So looking at the work now on diastrophism and the definition to it, we're going to check that information from the monitor and we'll go through that information together in class. The introduction to the work on diastrophism tells us that the lithosphere, of which we have already covered when we were looking at the different structures and layers of the Earth, is actually dynamic. Tectonic forces exerted by the movement of tectonic plates cause the fracturing, displacement, and buckling of the Earth's crust, as well as the flow of molten rock or magma. Volcanism concerns the flow of magma through the lithosphere, while diastrophism refers to the folding and the faulting processes. So for volcanism, we have covered that topic already, and it is mainly to look at the movement of magma from under the surface and the features it creates as a result of the solidifying of magma, and also movement of magma out onto the surface and the many features which are formed as a result of the solidifying of magma once it reaches the surface. And that was intrusive and also extrusive features associated with volcanicity that we have covered. So we look at diastrophism now, and the definition which is given tells us that, or generally, first of all, diastrophism is actually manifested in broad up-wrapping and a down-wrapping of crustal rocks, in close folding, and in displacement breaks in the rocks or faulting. These two words are important. They come under the topic of diastrophism, and the two words are folding and faulting of the Earth's crust. The result of all such movements are best observed, especially in layered sedimentary rocks, which were originally nearly horizontal. Wrapping is vertical crustal uplift or sinking. And many examples of broad up-wraps and down-wraps are actually known. We are going to actually look at some simple wrapping, and that will come under the work on folding of the lithosphere, or folding mainly of sedimentary rocks. Let's look at a simple definition now to what diastrophism is. And diastrophism is simply the deformation by folding and faulting of the Earth's crust under the influence of tectonic forces. That definition, I think it is simple and straightforward. So when we are looking at the deformation of the Earth's crust as a result of folding and faulting under the influence of tectonic forces, then one can say that topic is diastrophism. Okay, that definition you also have on the worksheets that were distributed. You can make reference to that later on. And since diastrophism has to do with folding and faulting of the Earth's crust, we are going to look at folding first of all, and then under folding we are going to look at the simple types of folds which are created as a result of the forces, tectonic forces, plus the two important forces that we will look at also in our lesson, the forces of compression and tension on the Earth's crust. And when those forces are actually exerted on the Earth's crust, it can contribute to the buckling of the Earth's crust, or it can contribute to the displacement, especially where there are faults or cracks. We will leave out faulting, and today we'll concentrate mainly on folding under the heading on diastrophism. Folding. When we look at folding, it talks about when layers of sedimentary rocks are actually compressed at the edges of or between tectonic plates, and when forces of compression are exerted on layers of sedimentary rocks, the layers of sedimentary rocks then will tend to buckle. You go back to the work that we've covered on plate movements, and we looked at the formation of fold mountains. We also found out that fold mountains, the major fold mountains around the world, they have been formed as a result of forces of compression or tectonic plate movements whereby plates collide or converge, come together. So when we look at the forces of compression, the forces of compression are similar to tectonic movements whereby plates collide or come together, or there is converging of plates. So you go back to looking at the work that we've covered on fold mountains, and we found out that most of the fold mountains in the world have been formed as a result of convergence of plates. And with that information, we can also say that the forces which are actually acting on the sedimentary layers of rock to create the fold mountains are the forces of compression. This particular process that's looking at compression now is known as folding, and it has been responsible for the formation of the world's great mountain ranges, example the Himalayas, the Andes, the Rockies, and etc. And folding of the Earth's crust results from the lateral forces of compression. Let's look at the information from the chart here, of which this information should also help us understand a little bit more about that force which is exerted on layers of sedimentary rock, resulting in the buckling of the Earth's crust. There are two important forces, but for our work on folding, we are going to concentrate on the forces of compression. When we look at the work on faulting, that's when tension will come in, and from the information here, we would now note that rocks of the Earth's crust are actually subjected to compression and tension when vertical or lateral earth movements actually take place. When we talk about vertical earth movements, we are looking at the displacement, especially of rocks on the Earth's surface, up or down. When we talk about the lateral earth movements, we are looking at displacement of the Earth's rocks sideways. Okay, and if we've looked at plate movements, especially in continental drift, the concept or the idea around continental drift, we found out that continents were actually moving away from each other or towards each other, and that movement can be classified as lateral movements. When we cover information on tension, then we are going to look at what we call vertical displacement. And in the vertical displacement, this is where we see the crust of the Earth, especially the rocks on the crust of the Earth, displaced up or down as a result of tectonic movements. But we will come to that when we cover the work on tension. We'll look at the first of those forces now, and that is to do with compression, because compression is to do mainly with folding. Points to remember on those two forces: rocks which are under tension, usually will fold. Rocks under compression, they may fault or fold. In tension, if this force is actually applied, then what will happen is faulting will take place. When rocks are actually under compression, they may fault or they may fold. We will concentrate mainly on compression with folding. And we will look at compression with faulting later, and we will look at tension with faulting later when we look at the information on faulting. Okay, looking at folding now. Folding is actually formed as a result of the forces of compression. And to show that in simple diagram, you have the two arrows acting towards each other to show the force of compression. The force of tension can be shown with a simple diagram of two arrows away from each other. And when the arrows are moving away from each other, then we say the force of tension is exerted on the layer of rocks. When the arrows are pointing towards each other, then we say the force of compression is exerted on a layer of rocks. Okay, we are concentrating now on this particular force here, the force of compression. When the force of compression is actually exerted on a layer of sedimentary rocks, then what will happen is that it will cause that sedimentary rock to buckle. And the buckling then comes under the heading on folding. A simple definition of what folding is simply folding is to do with the buckling of the Earth's crust under the influence of or under the force which is known as compression. We'll take an example, and maybe I will illustrate a very simple example using a piece of paper here. If we place this piece of paper on our table and we assume that that piece of paper is actually a block of land. Okay, so I have a piece of paper here on the table, and I am now saying that that piece of paper will represent a layer of sedimentary rock on the lithosphere, on the crust. If I am looking at the forces of compression, that means that my hand, when I put at the edge of that paper, will represent the forces of compression. And here we say the forces of compression will have to be acting towards each other. At the edge of maybe a layer of sedimentary rock, so this paper here might represent that. My hand will represent the force. If I had to actually force my hand on the edge of that paper together, then look at what happens to this piece of paper. I'm exerting the force here. What happens to the piece of paper? It folds, or it buckles. And that is actually exactly what happens also to the layers of sedimentary rock when the forces of compression is exerted on it. Okay? And when it falls, you can see there is an area which has been uplifted. And if the piece of paper is out here, and if I also exert pressure on the side, it might go down, sink. And what we are looking at here are some of the features which are created as a result of the folding of the Earth's crust. We'll move on now, and we'll look at the four main types of, or simple types of folding which occur as a result of that force of compression. Look at maybe from the monitor here some examples in reality of features that are created when the Earth's crust is actually put under the compressional forces. You can see here the different layers of sedimentary rock which have been either forced down or which have been forced up. Okay, I wonder if this diagram is actually clear enough for you to see the different layers and the way they have been folded. Can you see that? Okay. You can see here the different layers. If you did follow the different layers, then we are able to work out the way in which that particular layer has actually been folded. In folding also, we might end up looking at features of such as shown here. But from this particular diagram, it is showing us at least two simple types of fold which are formed as a result of the compressional forces exerted on a layer of sedimentary rock. And those two simple folds that we should be able to pick up is the uplifted area and also the depressed area. There are terms that we use to explaining or describing those uplifted area as a result of folding and the depressed area as a result of folding. And the uplifted area is this area here. There's two of them that you can see, 1 and 2. They are referred to as anticlines. The depressed area, there's one only from the diagram here, and that is a syncline. So far, we have looked at two simple types of fold that you must know about. If you look at the layer of sedimentary rock here, you can see this is an uplifted area giving us an anticline. There's another one here, an anticline. This area here is a depressed area, and the depressed area then, which is formed as a result of the buckling of the Earth's crust and as a result of compressional forces exerted on a layer of sedimentary rock, then what we end up with then is a syncline. So therefore, the four main types of fold, the simple types of fold that I'd like us to be able to recognize in our lesson today would be that of a monocline. A monocline is actually a type of fold. We should be able to recognize that as soon as we go to the information from the monitor and from our worksheet so that we are able to identify the main feature from a monocline. The second type of fold then is an anticline. The third type of simple fold is a syncline. And the fourth type of simple fold will be the overturned fold. You make reference now to your diagrams on the worksheet, and those diagrams will show you a three-dimensional drawing of those different features. Okay, we look at each one of those. First one of a monocline. Here is a photograph taken showing us an example of a monocline. Maybe if you look at that photograph, you might not be able to work out what makes it a monocline until you know what a monocline is and you are able to identify from pictures or diagrams. A monocline, definition given. It is a gentle bend or flexure with a steep-like form in horizontal bedded or gently dipping rock strata. In a monocline, the reason for why it is called a monocline is because if you look at this diagram, it tends to contain only one limb. And then when I'm making reference to a limb is actually one side to that particular feature. If I had to construct a one-dimensional diagram to show that feature, then a monocline would look something like this. When I talk about a limb, I'm looking at the slope or the side of that feature. And there's only one limb that a monocline has, and that is the reason for why it is known as a monocline, mono meaning one. And that's the one limb that that feature has. If we look at the layer of sedimentary rocks and the way that they have actually been folded, forces of compression exerting on the sides of this particular feature will result then in the formation of a monocline. The only difference is that the monocline has only one limb. The second example of a simple fold is that of a an anticline. So if we look at perhaps a photograph showing an anticline, again, we need to know what an anticline is for us to be able to pick up from the photograph. And you can see that the way in which the layers of rock have been folded. Okay, let's look at that information on an anticline. An anticline is an arched or upfold in the strata of the Earth's crust. This area up here, the upfold we are looking at. The two sides, this side here and the other side, or the limbs of the fold dip in opposite directions away from a crest line or a central axis. In other words, if we had the forces of compression exerted on a layer of sedimentary rock, the area which is actually uplifted is an anticline. The uplifted area, which is formed as a result of the forces of compression exerted on a layer of sedimentary rock, is an anticline. We looked at the example. We put a paper on the table and we actually add the force on the side of the paper. Then what happened was an upfolded area, of which that upfolded area is an anticline. Okay, let's look at the third example of a simple fold. Okay, if you look at the photograph here, you can see the feature. Okay, now we'll go through the explanation of what a syncline is. And it tells us here a downfold or basin-shaped fold of crustal rocks in which the strata dips inwards towards the central axis. In other words, when the forces of compression are exerted on a layer of sedimentary rock, the depressed area becomes a syncline. Okay, so it is this depressed area here which is referred to as a syncline. Okay, we move on. And the last or the final type of fold. And the last one is that of an overturned fold. If you look at the layers, it has actually been buckled so much that there is an overfold on the layers of sedimentary rocks. Okay, so we look at the information from the diagram. An overturned or an overfold is simply a fold in which the beds in one limb have been rotated through more than 90 degrees so that they are now inverted or overturned. So you can see here what has happened is that the layer has actually gone all the way there and then out again. So we can see an overturn in the strata or layer of sedimentary rock. If I had to construct a simple diagram on the board to show those four different types of fold that we have looked at, the first one has been done already, a monocline with one limb. We can have B, an anticline. This time you have two limbs, but the area which has been uplifted here is an anticline. Then we have C, a depressed area giving us a syncline. The arrows that I have on the side here represent the forces of compression. Here we can also put the arrows here to show the forces of compression. And finally D, the overturned fold. We can have the arrows on the side here to show the forces of compression. So basically, on the board here are dimensional diagrams, so very simple diagrams to illustrate those four different types of fold, which are examples of simple folds. Okay, before we move on, is there any question that you might have so far on those 4 examples? You have the worksheet there, of which that worksheet contains the information that I have just gone through. Any questions? Okay, bear in mind and remember the main force which is actually exerted to result in those 4 simple folds that we have looked at is the force of compression. Forces acting towards each other. Okay, if there are no questions, then we'll move on. On the chart here, I would like to also show that the diagrams that you see here from the information on the chart show a simple fold. The layers of rock which actually bend up would form an upfold, or the correct term that we'll use will be an anticline. Those that bend down, they formed a downfall, which are syncline. The sides of a fold are called the limb or the limbs. Say, for example, in a monocline, there is only one limb. That's why it is called a monocline. For an anticline, you can see the 2 limbs that are actually shown. Okay, we now look at what happens if we also have a layer of sedimentary rock and the forces of compression continuously acts on that layer. What would happen to that layer of sedimentary rock? Originally, before, we have 1, 2, 3 different layers of sedimentary rock. The forces which must act on this particular layer will have to be the forces of compression. So the arrows representing that. When forces of compression are exerted on a layer of sedimentary rock, then what will happen is that that layer is going to actually buckle. So if you look at the layers here, 1, 2, 3, and we come now to the next diagram, 1, 2, 3, still the same layers, but you can see now they have buckled because of the forces of compression. The upfolded area here, that will be the anticline. The depressed area then here becomes a syncline. Continuous exerting of that force of compression will end up creating a simple fold. Forces of compression continuously act on that same layer after a simple fold. Then what might happen is that one limb might become steeper than the other limb. So if you look at this limb here, in comparison to this particular limb here, you can see that this limb is actually steeper than this limb here. And when that happens, the fold becomes what is known as an asymmetrical fold. Continuous forces of compression still exerted on this particular layer will result then in one limb being forced under the other limb, resulting then in an overfold fold. And finally, if the pressure continues, then there might be a line of fracture or crack, resulting then in an overthrust fold or a nape to be actually formed. So you see, this diagram here shows us a simple stage in the different types of fold that can actually occur. That same information you will also find on your worksheet at the back of the worksheet. Okay, so we look at that information again from the monitor. Originally, forces of compression giving us a simple fold. Continuous force gives us an asymmetrical fold. Then we have an overfold, and then finally an overthrust fold or a nape. And note that the difference between a nape and those other folds is that here there is a line of fracture. One of the most common feature that you must recognize when you are trying to identify fold or folding is that there is no fracture or no crack actually involved in the formation of the features. When a fold or a crack is created, then that feature now becomes or can be classified under faulting. Okay, the stages, as I have explained: forces of compression exerted. You have a simple fold being created. You can see there an anticline and a syncline. You can see for the simple fold, the limbs are actually about the same on both sides. Continuous forces of compression, we'll see an asymmetrical fold of which one limb now becomes steeper. This side here becomes steeper than the other limb. And when you have one limb steeper than the other limb, that fold is referred to as an asymmetrical fold. Then you have an overfold, this time when one limb is actually pushed over the other limb. So this particular limb here is actually pushed over this limb. Forces of compression still exerted. And then finally, you have an overthrust fold. And that is when pressure is very great, a fracture occurs in the fold, and one limb is actually pushed forward over the other limb along the line of fracture. Okay, with those explanations, what I would like you to do now into your exercise book is I would like you to construct simple diagrams to actually show the four main types of fold, the four simple types of fold that we have looked at. And the four simple types of fold that we have looked at is the monocline, an anticline, a syncline, and an overturn. So in your exercise book, I'd like you to do your sketches, and I'd like you to construct simple diagrams to show those four types of fold that I have just gone through with you. Make note of that information also. Okay, class, I think with that information that will also bring us to the end of our lesson. But before I finish off, I'd like to recap on what we have covered already so far today. We looked at diastrophism and the definition to what diastrophism is, and it is simply to do with the deformation of the Earth's crust by folding and faulting under the influence of tectonic movements. Under diastrophism, there are two important topics of which we are going to cover. The first one is folding, and for folding, I also mentioned that it is to do with the buckling of the Earth's crust, resulting then in the formation of many different features on the lithosphere. The four examples of simple types of fold that we looked at today are that of a monocline, an anticline, a syncline, and a overturn fold. And note that the important force that is actually exerted on the layer of rocks to contribute to the type of folding is the force of compression. And the diagram here will simply show us the force of compression, that is forces which are acting towards each other. And that will also bring us to the end of the lesson. For your homework, I'd like you to ensure that you have your diagrams constructed and labeled in your exercise book. Okay, class, if you can now stand up. To the pilot teacher, our keyword for lesson 44 is fold. Good afternoon and thank you, students.